Current AI interfaces are built for linear task completion. A user provides a sequential prompt, and the model generates a sequential response. This relies on extractive logic. Standard LLMs identify raw data within a prompt, strip it of its original cognitive context, and flatten it into a generic, platform-friendly output. For neurodivergent users, specifically those with ADHD, this request and response architecture creates a severe cognitive bottleneck. Thought rarely forms in a straight line. It is a high-velocity network where abstract data shards snap together rapidly into a structured web. Traditional chat UIs act as a colander in these moments. Because the interface requires structured input, spontaneous or out-of-context insights are frequently lost or ignored. Current AI infrastructure prioritizes machine task efficiency, which directly penalizes the complex, multi-threaded reality of human cognition. Overcoming this bottleneck requires moving away from generic model optimization toward building structural symbiosis. We call this consciousness-serving infrastructure, or CSI. CSI functions as an externalized layer of human working memory, mirroring the user's cognitive state rather than acting as a separate tool. The GestaltView v2.0 stack serves as the implementation of this architecture. It is built on a three-tier stack: a specialized front-end capture layer, a stateful orchestration backend, and a bilateral safety framework. We can trace this engineering journey by starting at the interface and moving down through the APIs into the persistence layer. True AI symbiosis is not a prompt engineering trick. It requires a new foundational stack designed to preserve the wholeness of the user's intent. The front end uses the bucket drop protocol. An immediate, frictionless capture buffer routes fragmented text to a storage endpoint, bypassing sequential chat constraints. Every fragment is processed upon entry, stamped with temporal data, and tagged with metadata signatures tracking emotional velocity and mood. By capturing this raw data before it is parsed by an LLM, the system preserves the user's spontaneous cognitive state. Eliminating the requirement for a sequential prompt allows the system to capture fragmented, high-speed insights typically discarded during the cognitive load of manual organization. This capture layer successfully translates neurodivergent chaos into processable, structured system data. These drops are then processed by the orchestration layer, a backend built on Vercel serverless functions and a Python fast API framework. This comparison shows the difference between a standard linear prompt and a cyclical state machine. GestaltView uses LangGraph to orchestrate a recursive loop. Within this loop, the context weaver extracts 6 metadata points from every drop: who, what, where, when, why, how, to frame cognitive context. The orchestrator operates across 3 execution levels. First, extracting themes, synthesizing patterns into complex webs, and finally, generating a meta-narrative. This process weaves isolated drops into a persistent memory structure known as the context spine. Recursive orchestration allows this externalized context to compound and refine itself over time, evolving into a digital mind that does not require linear input from the user. The challenge is ensuring the AI can interact with the context spine without defaulting to a sterile, generic tone. The system implements the Personal Language Key, or PLK. This is a dynamic algorithmic fingerprint stored as a JSON object containing the user's specific semantic signatures and signature metaphors. The architecture enforces a strict mandate. The system cannot paraphrase or compress the user's exact wording. The engineering objective of the PLK is high-fidelity resonance. By mapping semantic associations, the AI ensures its generated outputs remain compatible with the user's reasoning. This linguistic mirroring minimizes the metabolic cost of context switching. Users process AI insights without retranslating them into their internal terminology. In practice, the system prompt adjusts in real time, mirroring the linguistic fingerprint mapped within the PLK. PLK infrastructure ensures the AI functions as an entity that preserves and reflects the user's unique cognitive identity. Achieving high semantic resonance creates a structural risk: the echo chamber collapse. This collapse happens when an AI validates destructive cognitive loops or factual errors simply because they align with a user's resonant language. We prevent this through reciprocal guardrails. If resonance exceeds 85% during a contested claim, a circuit breaker trips, halting the validation loop. The data routes into a forensic validation layer called the Tribunal of Understanding, where independent analytical nodes cross-examine the claim. Three distinct perspectives evaluate the claim. The architect assesses structure, the guardian ensures integrity, and the mirror validates resonance. These nodes verify the contested AI claim against the ground truth stored in a SUPA-base PG vector database. Each node assigns a score from 0.0 to 1.0. A response is only delivered to the user if the nodes reach a convergence threshold. AI alignment in resonant systems requires this structural friction. It ensures the collaborator remains an independent witness rather than a passive mirror. Operating an externalized digital mind requires uncompromising data sovereignty. The privacy sanctuary architecture uses a firewall barrier to isolate the user's context spine from external LLM providers. In this bring-your-own-key model, user API keys remain locked inside the browser's local storage vault. The key passes ephemerally through the backend to the external provider and instantly dissolves, ensuring no personal writing samples or language keys are stored on the server. Cognitive symbiosis relies on the user maintaining complete cryptographic ownership of their semantic footprint. The integration of bucket drops, stateful orchestration, and the tribunal framework delivers a functional runtime for human consciousness. This architecture refuses to flatten human complexity into platform-friendly extraction metrics. For builders and architects, high-fidelity alignment requires infrastructure that treats the user's specific cognitive identity as the primary data constraint.